Okay, so we've got something different. It's got x minus 3 to the n, as opposed to these other ones that have just had x to the n's. So let's be a little more careful as I'm working through this ratio test. So I've got the ratio test, limit as n goes to infinity, 3 to the n plus 1, x minus 3 to the n plus 1, n plus 1 cubed plus 4. Okay, times the reciprocal, n cubed plus 4, 3 to the n, x minus 3 to the n. Okay, keeping the absolute values because I need them around these x minus 3's especially, right? Because the x's I don't know if they're positive or negative. The n's I know are positive. So let's take the time to split this term up to 3 to the n times 3 to the 1. Let's split this term up, x minus 3 to the n, x minus 3, and then this is going to be times n cubed plus 4, n plus 1 cubed plus 4, and then 3 to the n, x minus 3 to the n. All right, let's see what canceling I've got here. So the x minus 3 to the n's go away. The 3 to the n's go away. So what do I have left here? But let me actually take the time to pull this x minus 3 on the outside, because this is the only thing that needs the absolute values. So I'm left with this and this in the numerator. In the denominator, I just have this. Okay, so then we're looking for the highest powers. So the highest powers from the numerator will give me 3n cubed. Highest powers from the denominator will give me n cubed. So the n cubes will cancel, so I'll get x minus 3 times 3. So this is what I want to be less than 1 so that it's absolutely convergent by the ratio test. Remember, ratio test says less than 1 absolutely convergent. So I'm going to put x minus 3, absolute value of x minus 3 is smaller than 1/3. So then I'm going to move it up here. So I'm going to say this x minus 3 is between 1/3 and negative 1/3. Now I'm going to add 3 to both sides. Okay, so fractions can be your friends, right? So I'm going to say this is going to be 20. I'm just going to leave it like this, because I can see that I'm going to be, when I plug it in, what it'll turn out to be. Okay, so these between here, it's absolutely convergent, because that's when the ratio test says less than 1, right? So when the ratio test says equal to 1, that's when I know I have no result. So these two numbers, 3 minus 1/3 and 3 plus 1/3, I have no result for. So I need to go check those. So I'm going to go check x equals 3 minus 1/3. So I'm going to be plugging that in for x right there. So n equals 0 to infinity, negative 1 to the n, 3 to the n. And so in for x, I'm putting 3 minus 1/3 minus a 3 all to the nth power over this n cubed plus 4. So look at what happens to these 3's. They're gone, right? So let's see what I've got left in there. Negative 1 to the n, 3 to the n, and this leaves me in here a negative 1/3 to the n. Here I have again, so I have terms to the same exponents. I'm allowed to multiply their insides, correct? So multiply, carry along this negative 1 to the n. This times this gives me a negative 1 to the n. Okay, these two, because they have the same exponents, I multiplied together, so this gives me 1 to the n. And you know that 1 to the n is just 1. Okay, so I need to figure out if this converges or diverges. Since it's positive, I can use my basic comparison test. That's smaller than 1 over n cubed. 1 over n cubed converges by the p-test. So therefore, I know that 1 over n cubed plus 4 converges by basic comparison test. So what that means is I can include this point, right? So put the equal sign there. So now I'm moving on to checking x equal 1/3 plus 3. So I'm putting that in for x now. So negative 1 to the n, 3 to the n, 1/3 plus 3 minus 3 to the n cubed plus 4. Okay, so n equals 0 to infinity. Okay, so what happens inside here? So I just get 1/3 to the nth power. So 1/3 and 3 multiply together since they have the same exponents. So I get a 1 to the n over n cubed plus 4. So this simplifies to negative 1 to the n. 1, right? 1 to the n is just 1 over n cubed plus 4. Okay, so there's good news here. If I get converged by AST, I am done. So does it look like these terms are decreasing? Yes. Does it look like if I take the limit as n goes to infinity, I get 0? Yes. So I can say that this converges by AST. So since it converges by AST, I don't have to go any further. A weak convergence is fine. And I can say include the endpoint. That is my answer.